Okay, this video is going to talk about functions and what we mean by functions. Functions are basically equations, and they're equations that end up with an x and a y. And the x is what we put in, what we put into the equation. And this giant machine here kind of represents what the equation is, right? And then what happens is when we put that x in the equation, out's going to pop our y, which we're going to turn and put in this spot here and populate it. So what I'm going to do is I'm going to put some values into this machine or into this equation, and I'm going to tell you what's going to pop out. And then based on that information, we're going to figure out what is this particular machine asking us to do, or in other words, what is the equation. So if I put a 3 in this machine and it goes through, it's going to pop out a 9. If I put a 2 in this machine, out's going to pop a 6. I'm going to put a 1 in this machine and out pops a 3. I'm going to put a 0 in this machine and out will pop a 0. When I put a -1 into the machine, because we can put negatives as well as positives, I'm going to get a -3. And when I put a -2 in the machine, out's going to pop a -6. So now what we have to do is figure out, based on this information, what's happening in this machine. What's going on? What's it having it do? What does y equal? Y equals what? What's happening to the x? We got to figure out here what's happening to the x, and we're going to put it in that spot, and that's going to give us our equation. So let's do some deductive reasoning and see what's happening. So let's always start. A good place to always start is with the 0. When you put a 0 in, you kind of see what happens. So if I put a 0 in this place for the x, it doesn't matter what this number is, the whole thing's going to go to 0. So we know that we're not adding 0, because if I was adding a 0, I would have that number as well. It could be x plus 2. Let's say if it was x plus, because we notice that when it goes 0, 1, 2, 3, it increases. So when things increase, okay, so when things are increasing, we can say that we are adding or that we are multiplying to get there. Now we can tell based on what's going on with the 0 if there's any adding going on. So if I put a 0 in the machine and out popped a 0, that means that in this particular machine there's no adding going on, because if I was adding something to that 0, that something would show up right here. So we know that no adding is going on to get this increasing value. That means that there has to be some multiplying going on to get here. So let's think about this. We're going to try and, like I said, use some deductive reasoning. We are going to put the number 1 in here. So if I put the value of 1 in for x, and I want it to equal 3, because that's what the pair came out with, what number would I put in here to make that happen? We would put the number 3 in there to make that happen. So what we think is going on in this particular machine is multiplying by 3. So let's see if that's true. We're going to check our way through the math and see if that's true. So is 3 times 3 9? Sure it is. 2 times 3 6. 1 times 3 is 3. -1 times 3 is -3. And -2 times 3 is -6. So we've just proven that these values would come out of a machine that did this particular equation, which is y equals 3x. Okay, so that's kind of how we look at it. These are called functions, and these functions, they're doing something, they're functioning. So in order for things to function correctly, every number that gets put into this particular machine gets multiplied by 3, and then afterwards your output, or what would happen, what would come out, we would put into that table. So we're going to do another one without all the big drawings, and I'm just going to show you a table, and we're going to use some deductive reasoning. And we just talked about how increasing, when we're increasing, we're using adding or multiplying. The same thing would be true for when we're decreasing. Okay, so let me find a little room right here. and I'm going to write this over. Actually, I can write it over here on the side. When things are decreasing, we are going to then either be subtracting or dividing. And the reason that's true is because these two make things go down. Okay, subtracting and dividing make things go down. We're adding and multiplying make things go up, make those numbers go increase or decrease, and so on and so forth. So we got to be mindful of our operations, and hopefully that will help us through this. So let's take a look at another one. Here we go. We're going to take a look at this and what's going in the machine and what's coming out of the machine. So in the machine, remember this is our X, and coming out of the machine is our Y. So we're going to try and figure out what's going on. So like I said, we always want to start from the zero. When we input a zero, we usually can tell what's happening. Is there multiplying going on, dividing, subtracting, whatever. So if we start from the zero and we go up 1, 2, 3, as this is increasing, we see that this is increasing. So that the fact that these are both increasing at the same time, that means that we are having an increase going on. So we're looking for something that we're looking for some adding and or multiplying. It could be both. So we got to be on the lookout for that. Okay. So because I'm putting in a 0 and out pops a 2, we know that we're going to have to start with adding, because if 0 goes in and out comes a 2, we know what's happening is we know the minimum that's happening is the number that gets put in is going to get added by 2. Okay, so let's see what happens now. We know this much. Y equals, we know this much. What's happening to the X? Let's see if it's a single X or something's happening. If I put a 1 in this spot, is 1 plus 2 equal to 3? 1 plus 2 is 3, and we see that that's equal, so that checks. So far, this is looking like the rule. It's looking like what the equation would be. So let's try another one. I put a 2 in. 2 plus 2 is 4. That works. I put a 3 in. 3 plus 2 is 5. That one works. We know that this works because that's what we're building our rule on, right? So let's put a -1 in there. -1 plus 2. Well, -1 plus 2 yields a +1, which is where we are here. And if I put a -2 in, well, these are opposites, -2 and +2, so we know that equals 0, so that checks. So all of these pairs will work for this particular equation, will work for this particular rule or function. Okay, let's try another one. Here I have another set of pairs. And again, remember, we're always going to start at the 0, because at the 0 we're going to see. So as this is increasing, this is also increasing. So we know that something positive is going on. So it's either being added to, so we're looking for either adding or multiplying, because they're both going up. And if a 0 goes in and there's nothing coming over here, we know that adding is off the table, because there would be something there being added to it if that was going on. All right. So now we have to decide. We know that y equals, there's some multiplying going on, we don't know what, times the x. So when we put 0 in there, that works. So let's skip this 1/2 for a second, because that's a little weird. Let's jump to the 2. It's saying that if I put 2 in this spot, I'm going to be multiplying it times something. In fact, I did those backwards, so let me change this. I'm looking for, what would I multiply by 2 to get 1? Well, what's interesting is basically it's saying I'm taking 2, but I really want 1. I have 2, but I want 1. So we're really taking half of 2, aren't we? So we're taking half of 2. So that's saying that we're putting a half in here. Let's see if that works, if 1/2 really truly works in this situation. So let's try. So we know it works for this one. We know it works for this one. Let's put a 1 in this spot. So if I said, what does 1/2 times 1 equal? Well, 1/2 times 1 equals 1/2, doesn't it? And so that's what we have here. I put a 1 and out comes 1/2. So this is looking really good so far. If I put a 3 in this spot, 3 times 1/2 or 3 halves. If I have 3 halves, I'm going to get 1 1/2. There it is. Boom, works there. Let's try the negative. 1/2 times -1. There's your -1/2. And here, if I put a -2 in here, -2 times 1/2, I need halves, 2 negative halves, that's going to be 1 negative whole. So yeah, so this one works all the way down. So this is our rule. This is what we're looking at, okay? I got a few more. See if I can get them here. Okay, I'm going to do a horizontal table this time, and that way we can get some more numbers in. So again, we're going to look at this 0, right? And when we're looking at this 0, this is saying -5. Well, that's kind of interesting, right? So let's see what's happening here. 1, 2, 3, 4, 5. This is increasing, right? So as we're going this direction, things are going up. And as we go this direction, things are also going up. They're not decreasing. So we could be adding something. But what are we adding to get to this -5? Well, we could be adding a -5, couldn't we? And what's the same thing as adding a -5? It's the same thing as subtracting 5. So whatever, we're doing something to the x, right? We don't know what that something is yet. We're going to do something to the x, and then we're going to subtract 5 or have a -5. So let's try and see what happens when we go into the next spot. Let's take it from the positive side. So if I put a +1 in this spot, so if I say something times 1 minus 5 will equal -4. So this is what it's saying. Something times something times 1 minus 5 equals -4. So let's see if we need to multiply that 1 times something to make it happen first. So if I cover this up, 1 minus 5, well, I know 1 minus 5 is -4. So since these are both the same, that means there's nothing else going on in front. There's no multiplying. I don't need to take it a step further. So if I don't need to take it a step further, then I know that my equation is y equals x minus 5. So whatever number I'm going to put in here, I'm going to subtract 5. So let's check and make sure that we're right with that. So we know that it works for the 1. Let's put a 2 in here. Does 2 take away 5 equal -3? Yes. Does 3 minus 5 equal -2? Yes. 4 minus 5 equal -1? Yes. Is 5 minus 5 0? Correct. So it's proving that it works this way. It's also going to work that way. If the rule keeps working all the way in this direction, it's going to work in that direction. So our rule is, and I don't know if you can see it here, I'm going to move it over a little bit here. Our rule is y equals x minus 5. That's going to be our equation or our rule, okay? All right, we're going to take a look at another one now. Move it on down here. Okay, move this one up. All right, so here, once again, we're going to kind of take a look at the zeros. And when we look at the zeros, nothing's happening. Okay, so when nothing's happening, we're kind of, okay, that means there's no adding or subtracting going on. We're just multiplying something out. So we know it's y equals something times x. We have to figure out what that something is. It could be multiplying or dividing. So let's take a look here. As 1, 2, 3, 4, 5, this is going up, -2, -4, this is going down. So as 1 is going up, 1 is going down. Because they're going in opposite directions, right? They're not going in the same direction. We know a positive times a negative is negative. So we know that this has to be a negative because they're going in opposite directions. If they were going the same direction, they would both be positive. So let's figure out what number we would put in for this. So if I take a 1 and put it in this place of x, so I want to put something that's negative, I don't know what, and I'm going to multiply it times 1 is going to equal -2. So what number, let me erase this because we don't need that yet. What number times 1 will give me -2? Well, it's -2, isn't it? And that kind of lends itself to what we're looking for. We are kind of looking for a negative number. So let's see if multiplying by -2 is what's going to happen as we go through here. So we know it works for this one. Is 2 times -2 -4? Yes. 3 times -2 -6? Yes. 4 times -2 is -8? Yes. 5 times -2 is -10. So we know it works this way. It'll also work for the negatives. So this is our equation. So we're going to write over here y equals negative 2x. Okay? All right, we're going to take a look at some more. I think I got 3 more for you. Okay, here we go with this one. Let's take a look at the whole thing here. Okay, find the 0. Okay, we're going to find the 0 right here, and we see a 2. The fact that we see a positive 2, we know in our rule automatically that we're going to add 2. Because we're going to put a 0 next to the x. We know if I put 0 in here, 0 plus 2 is going to be 0. So far I know that. I just need to know, is there a number in front of that x? That's what I need to find now. So as this is going up, 1, 2, 3, 4, 5, this is going up. 2, 4, 6, 8, 10, that's also going up. So they're going in the same direction, so we know that this is positive. So now we're going to test some numbers. Let's test the 2. Let's jump over here and test the 2. So I want it to equal 6, which is the output. And what number would I multiply times 2 and add 2 to it to get 6? Now, if you remember about doing your equations and solving for equations, we could subtract 2 from both sides, right? And then that tells me that 4 equals something times 2. Well, I hope you guys know something times 2. That means that has to equal 2, doesn't it? So I think that that's a 2 there. That's a 2x plus 2. So let's test it and see if we're right. So we know it works for this one. Let's put a 1 in here and see if it works. 1 times 2 is 2. 2 plus 2 is 4. That works. Put a 3 in here. 2 times 3 is 6. 6 plus 2 is 8. That one works. Put a 4 in. 4 times 2 is 8. 8 plus 2 is 10. Put a 5 in. 5 times 2 is 10. 10 plus 2 is 12. So we see that it works there. So this is our rule. And that's the rule we're going to write over here on the side. Y equals 2x plus 2. Okay? So you can see the functions are getting a little bit more involved, a little bit bigger. Different things are happening. Let's do another one where a couple of things are happening at the same time. Okay? So here we have this one. And once again, we're going to focus on the 0. And when we focus on the 0, we see that there's this minus 3 going on. So we know that to get the output, whatever is happening to the x, which we're going to try and find out what that is, we know that we have to subtract 3 from it, no matter what, because that's how that negative 3 comes about. If this is 0, and that goes away, that has to equal negative 3. So we know that that's there. So the question then becomes, what happens? So let's take a look. 1, 2, 3, 4, 5. This is going up. Negative 4, negative 5, negative 6, negative 7, negative 8. Ooh, this is going down. So we're going in opposite directions. Because we're going in opposite directions, that means that this is negative. Whatever is happening is negative. It's going to go in the opposite direction. So let's try and figure out what number that could possibly be. Let's do the number 1 here, this one right here. So we want to know it's going to equal negative 4. We don't know, which we're trying to find out. And we're going to stick in the number 1 in the x spot. And I'm going to subtract 3. So we're going to figure out how that works. So first step, remember, add 3 to both sides. That's going to help. That's going to make that go away. And negative 4 plus 3 is negative 1. So it's asking what number times 1 will equal negative 1. Well, hopefully we realize that that equals negative 1. So that means that this needs to be a negative 1x. Let's find out if that is true. If I put a 2 in this spot, 2 times negative 1 is negative 2. Negative 2 minus 3 is negative 5. I put a 3 in this spot. 3 times negative 1 is negative 3. Negative 3 minus 3 more, negative 6. I put a 4 in this spot. 4 times negative 1 is negative 4. Negative 4 minus 3 is negative 7. We can see it's working, right? I put a 5 in this spot. 5 times negative 1 is negative 5. Negative 5 minus 3 is negative 8. So since it works here, we know it's going to work over here for the negatives as well. So this is our rule. Now you could write it as y equals negative x minus 3. You don't necessarily need to have that 1 in front of it. So what we're going to do is we're going to go over here and we're going to write our rule down. Y equals negative x minus 3. So we've got that. Okay, we've got one more to go. So this is our last one that we're going to do. Okay, and let's see if we can figure out what's happening. So if I'm looking at the zeros, right, because that's where I start, I look at the zeros. Here's the zeros, and nothing's happening. So that's good. So I know I'm y equals something x. There's nothing out here. Something's happening to the x. So 1, 2, 3, 4, 5, that's going up. 1, 4, 9, 16, 25, that's going up. But look at what's interesting. It's going up, but something weird is going on. See all these other ones were going up like by 2, 4, 6, very small. Here things are changing dramatically. We might say things are changing exponentially. Things are climbing very, very quickly, and that's what we mean by exponentially. So let's see if we can figure out something. What would I do to a 1, right? What would I do to a 1 to equal 1? Well, we know that that would equal 1, so that's not really going to help us there. So what we want to do then is to find out what will we do. Let's do the 2. So what will I do to equal 4? What will I do to this 2 exponentially, right? So we're going to do exponentially. That means we're looking for a number to put here to make it equal 4. Well, I believe that would be a 2, right? Because 2 squared is 4. So let's test it with the 3. We know it works here. We know it works here. Let's test it with the 3. So if I put 3 and I square it, because I think that's what's going on, 3 times 3, what does that equal? Well, that equals 9. And that's what we got. And check this out. 4 times 4 is 16. 5 times 5 is 25. And it works over here on the negatives because we know negative 2 times negative 2 is positive 4. So this happens to be an exponential function. Okay? So we're going to write y equals x squared. So that's why sometimes you really need to look at the numbers as well. Not if they're increasing or decreasing, but how much they're increasing and decreasing. So hopefully this little function activity help explains functions and how to find a rule.